Hello students, in last class we learnt about the fundamental theorem of arithmetics, its statement and few simple problems related to that. And now in today's mathematics session we are going to find the LCM and HCF of the given numbers using that fundamental theorem of arithmetics. Already you learnt about this LCM and HCF, finding LCM and HCF for the given numbers using prime factorization method and by using definition method, division method, everything in your earlier classes. And now in previous video 4 we already discussed at the Euclid's division algorithm the definition method as well as the division method for finding HCF of two given numbers, right? So already we discussed this definition method and the division method for finding the HCF of the numbers in the previous video. So now in this video, in this session, I am going to recall the definition method and division method for finding LCM of the given numbers. And after that, I am going to deal with the way of finding LCM and HCF using the fundamental theorem of arithmetics or by prime factorization method. And now this video is about the least common multiple LCM as well as the highest common factor HCF, right? See, right now least common multiple, we are going to recall the definition method for the LCM. So how to find LCM using definition method? For that we need to know about multiple and we need to list out the common multiples of the given numbers, and among all those common multiples you need to identify the least common multiple. For suppose if I have numbers 12 and 8, for 12 and 8, what is the LCM of this 12 and 8 by the definition method? So for that we are moving with the definition method that involves with the listing of the numbers. See, take 12. See, what are the multiples of 12? I am going to list out the multiples of 12. What are the multiples of 12? If you list out multiples of 12, a multiple is just nothing but multiplying that particular number with some other naturals. See, 12 I have, if you multiply 12 with 1, it's a multiple of 12. 12 with 2, 24 is another multiple. 12 with 3, 36 is another multiple. So the multiples of 12 are nothing but 12, 24, 12 3 is 36, 12 4 is 48, 12 5 is 60, and then I continue like that. And now what are the multiples of 18? If you think about the multiples of 18, we need to list out the multiples of 18. That in the sense continuously we need to multiply 18 with the natural numbers. So the numbers which we get in the 18 table, 18, 18 2 is 36, 18 3 is 54 and 72 and so on. And now you just list out the common multiples of 12 and 18. If you list out the common multiples, those common multiples are just nothing but what? See, 36 is the first common multiple, and then 18 4 72, 12 6 72 is the common multiple. So the common multiples are 36, 72 and so on. All these are the common multiples, right? And among these common multiples, 36, 72 and the next thing is 108 is another common multiple. And among the list of common multiples, if you identify this 36 is the least number, and that's why we call this 36 as the least common multiple, right? So whereas, see, the multiples are infinite actually. Factors for a number are finite, but multiples for a number are infinite. And similarly, if you move, common multiples are also infinite. Since common multiples are infinite collection, we can't say the highest common multiple. We are allowed to say the least common multiple, and that least common multiple usually notated as LCM, and that is just nothing but 36 in this particular example. So this is the way of finding the LCM for 12 and 18 just by using the definition method. And how to find the LCM of 12 and 18 by using division method. Finding LCM for 12 and 18 by using division method already you learnt in your earlier classes. For example, if I have 12 and 18 with me, so how to find? See, for example, I am using this space here. See, 12, 1, 18. I need to find LCM for this 12, 1, 18. How to do? I need to go with the number 2, right? 2, 6 is 12, 2, 9 is 18. And here it is 6 and 9. Then choose a number which divides this 6 and 9. 3, 3 2s is 6, 3 3s is 9. And now further splitting is not possible here. So by division method, the LCM is just nothing but 2 into 3 into 2 into 3. You need to multiply all these 4 numbers. And if you multiply all these 4 numbers, it is 36. And the 36 is the least common multiple for the given numbers. And this is the way of finding the least common multiple of the given numbers, in particular 12 and 18, by the basic definition method as well as the division method. And in previous videos, number 4, already we discussed the way of finding the HCF by definition method and division method. Okay, and next we are going to find the LCM and HCF for the given numbers by prime factorization method or by using fundamental theorem of arithmetics. Now, finding LCM and HCF by prime factorization method. Using prime factorization method is just nothing but using the statement of the fundamental theorem of arithmetics, because both are similar, right? And now, how to find the LCM and HCF for the given numbers used in this method? See, first of all, you need to prime factorize the given numbers to find the HCF and LCM of the given numbers. The first step you need to do is prime factorize the given numbers. Express the given numbers as product of primes. That's it. And the next step is, after prime factorization, you need to observe the prime factors, and from there, LCM is just nothing but the product of greatest powers of each prime factors. What is LCM? LCM is the product of greatest powers of each prime factors. See, you need to observe the prime factors and identify the greatest powers. You need to multiply the greatest powers of each prime factors, and that was LCM, right? We are going to discuss one example here. And then what is HCF? HCF is product of smallest powers of each common prime factors. For HCF, you need to note that common prime factors, whereas for LCM, you need to note that each prime factor. And for LCM, you need to identify the greatest powers. And for HCF, you need to identify the smallest powers. And at the end, after identifying the smallest powers along with the common prime factors, you need to multiply all those things to get LCM as well as HCF. And now, look at the numbers 12 and 18. So we need to find LCM and HCF for the numbers 12 and 18. What is the first step? The first step is just we need to prime factorize 12 and 18. So we know the prime factorization for 12 as well as 18. So I am writing here, see 12. 12 is what actually? 12 is just 4 into 3. And that 4 is nothing but 2 square. So the prime factorization for 12 is just nothing but 2 square into 3. Right, there ends the prime factorization for 12. Then what you say about the 18? 18 is just 2 into 9, so I can write it like 2 into 3 square. So 2 into 3 square is the prime factorization for 18. So I have prime factorization for 12 as well as prime factorization for 18. Next, we need to find the LCM for 12 comma 18. How to find the LCM for 12 comma 18? And now you need to utilize this particular definition. What it says? You need to multiply the greatest powers of each prime factors. See, what are the prime factors, prime numbers involved in this prime factorization? Look there. See, what are the numbers involved here? See, the numbers involved here are 2 and 3, that's it. And you need to identify the greatest powers of those primes, right? So to find the LCM, the step what we need to do is, you need to observe prime factors. Okay? You need to observe prime factors, and then you need to note greatest powers. Prime factors and greatest powers. The prime factors involved in this situation are 2 comma 3. You need to identify all the prime factors involved, each prime factor for LCM. And what you say about the greatest powers? For 2, if you take, the greatest powers are what? Here power 2 and here it is power 1, right? So the greatest power is 2. So for 2, the greatest power is 2. And coming to the prime number 3, here 3 power 1, here 3 power 2, again the greatest power is 2. So the involved prime numbers here are 2 and 3. And for the prime number 2, the greatest power is 2, and for the prime number 3, the greatest power is 2. Now at the end, see, prime number is 2, its power is 2. Prime number is 3, its power is 2. Therefore, we write it like 2 square into 3 square. We need to multiply product of greatest powers of each prime factor. Each prime factor 2, 3. Greatest powers 2, 2. Product we need to do for the greatest powers of these primes. So 2 square into 3 square is the LCM. And that 2 square into 3 square is just nothing but 4 9s, and which is 36. Right? So the LCM for 12 and 18 is just nothing but 36. Already we found that LCM of 12 and 13 just by definition method and division method earlier, and it is the same, that 36. So this is the way of finding LCM for the two numbers using prime factorization method. And now, how to find the HCF of those two numbers? Now, see, to find HCF, again, we need to do the prime factorization first. So already I have the prime factorization for 12 and the prime factorization for 18. Now what is my task? Now my task is finding HCF for 12 and 18. So to find HCF for 12 and 18, we need to concentrate on the common prime factors. I am repeating, common prime factors. You need to identify the common prime factors for the given numbers. Here 2 and 3 both are common prime factors in this particular example. So you need to note here common prime factors, right? See, common primes, what are the common primes here? Again 2 and 3. And after that you need to identify the smallest powers, right? See, for the LCM we observe the greatest powers, and for HCF we need to identify the smallest powers. And for the first number, the common prime number is 2, its power is 2 for 12, its power is 1 for 18. Among these powers 2 and 1, the smallest power is 1. And coming to 3, power 1 for the first number, power 2 for the second number, the smallest power is 1 again. And now the common primes are 2 and 3, and their corresponding smallest powers are 1 and 1. Then what to do? We need to multiply product of smallest powers of the common prime factors. Common prime factors and their smallest powers, we need to multiply. What we need to multiply? Power of 2 is 1, so 2 power 1 into power of 3 is 1, 3 power 1. So 2 power 1 into 3 power 1. So 2 power 1 into 3 power 1 is just 6, and that 6 is the HCF of these two numbers. Already we did it by definition method and division method in previous videos, right? And this is the way of finding HCF using prime factorization method. Just note that to find the LCM, you need to list each prime factor along with their greatest powers, and then you need to multiply. And to find HCF, list out the common prime factors along with the smallest powers, and we need to multiply. By using these two definitions, these two rules, we usually find the LCM and HCF for the given numbers, right? So usually definition method is helpful for the smaller numbers. For bigger numbers, the listing the multiples, listing the factors is somewhat risky process, right? Whereas division method is helpful for only two numbers, right? But whereas this prime factorization method is helpful for the larger numbers, and not only for two numbers, it is easy to find the LCM and HCF for more than two numbers also. And I am going to give you some more examples to find the LCM and HCF. Let us look at the side representing the rules to find LCM and HCF of the given numbers. See, the rule to find the LCM is product of greatest powers of each prime factors of the given numbers. You need to note the greatest powers along with each prime factor for the LCM. And HCF is the product of smallest powers of each common prime factors of the given numbers. You just note here that the common prime factors along with the smallest powers to find the HCF. Now, look at the board. I have two problems to find LCM and HCF. Problem 1 is finding LCM and HCF for two numbers 72 and 108. And problem 2 is finding LCM and HCF for three given numbers. This prime factorization method is basically helps us to find LCM and HCF not only for two numbers, more than two, for three, for four, any number of numbers if you have. Thus prime factorization method is very easy to find LCM and HCF. Now, first of all, let us solve the first one. See, for 72 and 108, we need to find what? LCM and HCF. First step to do is identifying its prime factorization. So, 72, what is its prime factorization? 72 can be prime factorized as 2, see 72 is basically what? 8 into 9, or you may go with usual prime factorization technique. 72 is 8 into 9, and which is nothing but 2 cube into 3 square. So the prime factorization for 72 is 2 cube into 3 square. 8 is nothing but 2 cube and 9 is nothing but 3 square, right? And whereas coming for the 108, what is the prime factorization for 108? See, 108 is just nothing but 2 into 54, is it right? And 54 can be further classified as 2 into 27, right? That in the sense, this is just nothing but 2 square into 3 cube. 2 square is 4, 3 cube is 27, and its product is 108. So, 72 is 2 cube into 3 square, 108 is 2 square into 3 cube, and these two are the representations as prime factors. And after representing the given numbers in prime factorization way, we need to identify LCM and HCF, right? LCM. So to find out the LCM, what we need to observe? We need to observe common prime, we need to observe the all prime factors along with the greatest powers. See, what are the prime factors? You need to identify prime factors along with the greatest powers. Prime factors and then greatest powers. Look there. See, the prime factors are 2 and 3. Involved prime factors in the prime factorization of the two numbers are 2 and 3. So 2 and 3. Then what you say about the greatest powers? For 2, the power is 3 in the first number, power is 2 in the second number, and among these 3 and 2, the greatest power is 3. So 3 is the greatest power for 2. Then coming to the prime factor 3, what you say about the greatest power? First number the power is 2, second number the power is 3, the greatest power is again 3 here. So for 2 comma 3, the prime factors, the greatest powers are 3 and 3. Then the LCM of these two is nothing but product of the greatest powers of the prime factors. That means 2 power 3 into 3 power 3. 2 power 3 into 3 power 3 is the LCM. And further you need to multiply it to get the answer, right? This is the LCM of the given numbers. And now, whereas if you wish to find the HCF of the given numbers, how to find the HCF of the given numbers? Now, you need to identify the common prime factors along with the smallest powers. So, common prime factors along with the smallest powers. See, what are the involved common primes along with the smallest powers? Yeah, look here, the common primes are again 2 and 3. So, the common primes are 2 and 3. And the smallest powers you need to identify. For the number 2, power is 3 in the first number, power is 2 in the second number. Among these powers, the smallest power is 2. So you need to note that smallest power. Then coming to the prime factor 3, power 2 in the first number, power 3 in the second number, the smallest power is 2 again. And now, see, you need to multiply the smallest powers of the common primes. That in the sense, 2 power 2 into 3 power 2 is the HCF of the given numbers. 2 square is 4, 3 square is 9, 9 4 36 is the HCF of the given numbers. And at the end, the LCM of the given numbers 72 and 108 is 2 cube into 3 cube is the LCM, and 2 square into 3 square is the HCF. Just by identifying the prime factors with the greatest powers and by identifying the common primes with the smallest powers, I found the LCM and HCF for the problem 1. And by applying the similar process, we need to calculate the LCM and HCF for problem 2. Now, look at the problem number 2. To find the LCM and HCF. See, the first number is what? 2 cube into 3 power 4 into 5. The second number is 2 square into 3 into 7 square. Whereas the third number is 2 into 3 square into 5 into 7. The numbers itself given as a product of primes. So, no need to do prime factorization for the given numbers because they are itself in prime factorization. Now, see, we need to find the LCM and HCF for these three numbers. The first thing is to find LCM. How to find the LCM? The basic definition in finding the LCM by prime factorization method is product of the greatest powers of the prime factors. All the involved prime factors you need to note and it's their corresponding greatest powers. So list them. See, prime factors, all the involved prime factors along with the greatest powers. Right. See, what are the involved prime factors? 2 is involved, 3 is involved, 5 is involved, as well as 7 is also involved in these three numbers. And now, for 2, you need to identify the greatest power. In the first number, power of 2 is 3. Second number, power of 2 is 2. Third number, power of 2, nothing is there, just it is 1. So, the powers of 2 are 1, 2, 3. Among these three, the greatest power is 3. So, the greatest power for the prime factor 2 is 3. And now, what to say about the greatest power for the prime factor 3? See, for 3, power is 4. For 3, power is 1. For 3, power is 2. Among those three, the greatest power is 4. Again, coming to 5. Here, 5, power 1 is there. Nothing in the sense, 1 is there for 1 as a power for 5. So, and in this number, 5 is not involved. So, since 5 is not involved, so you need to bother about the power of that 5. Right? Or you may treat that, this number like this. If you may treat it as something like 2 square into 3 power 1 into 5 power 0 into 7 square. Since 5 is not involved, you may write it like 5 power 0. That in the sense the power of 5 is 0. Or otherwise, since 5 is not involved, just you don't think about the power of 5, leave it and move for the next number. No problem, right? In this number, power 1. In this number, power no power, or you may say it as 0. Or in this, the power of 5 is 1. We need to identify the greatest power. So the greatest power is 1 only. So for 5, the greatest power is 1. And whereas, coming to 7, what you say about the greatest power? See, for 7, not involved here, so neglect it. 7 involved here, and its greatest power is 2. Power is 2, right? And 7 involved here, its power is 1. And to note the greatest power for the 7, here power is 1, and here power is 2, here no power, and the greatest power is 2 here. And now look at the numbers. See, these are the involved prime factors in the prime factorization of those numbers, and these are the greatest powers. The definition to find the LCM is the product of the greatest powers of the prime factors. So we need to multiply these things, the prime factors along with these powers. So at the end, the LCM is given by 2 cube, 2 power 3 into 3 power 4 into 5 power 1 into 7 power 2, and at the end, this is the LCM for the given three numbers. And now this is the LCM. Then to find the HCF, you need to list out common prime factors along with the smallest powers, and you need to multiply all those things. And now, to find the HCF of these three numbers, we need to identify the common prime factors, right? What are the common primes involved for the three numbers? Along with these common primes, you need to note smallest powers. Common primes along with the smallest powers. See, 2 is a prime factor, 2 is a prime factor, 2 is a prime factor, so 2 is a common prime. Here 3 is a prime factor, 3 is a prime factor, 3 is a prime factor, so 3 is a common prime. But whereas coming to 5, here 5 is a prime factor, here also 5 is a prime factor, but 5 is not involved in the second number, so 5 is not a common prime, right? So leave that 5. Then think about 7. Here 7 is not involved, but in these two numbers 7 is involved, that in the sense 7 is common for these two numbers but not common for all the three. So no need to identify 7 also here. So the only involved common primes are just 2 and 3. And after identifying the common primes, look at the powers. Now power of 2 is 3 in the first number, power of 2 is 2 in the second number, power of 2 is 1 in the third number. What is the smallest power? Among all those powers, 1 is the smallest power. Now look at 3. Power of 3 is 4 here, power of 3 is 1 here, power of 3 is 2 here. Among these powers, 4, 1 and 2, smallest power is again what? 1. So I have common primes along with the smallest powers, and now the product of the smallest powers of these common primes is the HCF. So 2 power 1 into 3 power 1 is the HCF. At the end, 6 is the HCF of these three given numbers. So this is the way of finding LCM and HCF of the given numbers using prime factorization method. We learned the way of finding LCM and HCF for the given numbers using different methods: definition method, division method, prime factorization method. And now let us observe few things related to the LCM and HCF. For suppose if I have two numbers A and B, and if you find LCM and HCF of these two numbers, say LCM of AB as well as HCF of AB, and think that what is the HCF? HCF is the highest common factor, that in the sense common factor of A and B, that in the sense factor for both A and B. So HCF is factor for A comma B, whereas LCM is a number which is in the list of common multiples. LCM is a number which is the multiple of A and B. So what I am going to tell you is this HCF is always factor for the numbers, LCM is always multiple for the numbers, and that in turn represents this HCF is factor for this and these are the factors for LCM. So I may conclude that HCF of given numbers is factor for LCM. This is one of the useful observation to solve some problems. So always for the given numbers, if you find LCM and HCF, that HCF is a factor of LCM. And another observation here it is, if you have numbers A and B, find their LCM and HCF. After finding that LCM and HCF, if you observe, always HCF of the two numbers A and AB when multiplied with LCM of the two numbers AB is equals to the product of the numbers. Very useful thing related to the LCM, HCF and along with the numbers. What it is? Product of the numbers A and B is equal to the product of their LCM and HCF. For suppose if you look an example, already we found the LCM and HCF for 12, 18. What is the LCM and HCF for this for 12, 18? What we found? We found the LCM by using all the three methods, and that LCM is nothing but 36 here, right? And what you say about the HCF of the numbers? And the HCF of the numbers, we found it as 6. So for 12, 18, LCM is 36, HCF is 6. Now think about the first observation. HCF is a factor of LCM. Is it right? Absolutely. 6 is a factor for LCM. The first statement is correct. Now think about the second statement. HCF into LCM is equals to the product of the numbers. That in the sense, multiplication of 12 and 18. 12 into 18, product of the numbers, is equals to the HCF 6 into 36. These both are equal, right? And this is the second identification, right? And now I am going to give you one example related to this second identification. Look at the problem on the board. The third problem of today's class. See, the problem says that LCM and HCF of two numbers are 180 and 6. LCM is given as 180. No need to find the LCM. HCF is also given as 6. See, these 180 and 6 are LCM and HCF of two numbers, but among those two numbers, one number is given as 30 and they are asking us to find this other number. Actually, we have only one number 30 in the problem. We don't know the second number. That second number we need to find with that LCM and HCF. See, just we observed a relation between the LCM and HCF along with the numbers, that HCF into LCM is equals to product of two numbers, and this relation helps only for two numbers, right? And here the problem involves with only two numbers, so this is acceptable to use. And now see, I have only one number, which is 30. I don't have other number. Let it as b. Let other number is equals to b. And if you let that other number as b, then by that relation, HCF into LCM is a into b. HCF is given as 6. So 6 into LCM of those two numbers is given as 180. 180 is equals to a into b. First number when multiplied with second number. What is the first number? It is given as 30. And the second number I don't know, I let it as b, so 30 into b. Just using this relation, I am going to find the second number. HCF into LCM is equals to 30 into b. I need to find b, so send this 30 that side. Then b is equals to 6 into 180 divided by 30. And we know that 36 jar is 180, 6 into 6 is 36, and b value is 36. The other number involved in the problem is 36, right? So look at the problem. The problem gives us LCM and HCF along with one number and asking us to find the other number. Using this relation, we found that other number as 36. And now this is another interesting idea related to the LCM and HCF. At the end, in this class, we learnt about the finding LCM and HCF using prime factorization method. And one relation related to the LCM and HCF. And now look at the slide on your screen. Contains few problems related to the things what we discussed in today's class. You need to solve this. Thank you.